Shubhamangalam at Little Scholars. Myself Subdeep. I will be taking up class 8 for today. We will continue with chapter 1 force. Let's solve the multiple choice questions together. And we are on page number 17, your textbook. Okay, you're going to open your textbook to page number 17 to mark the MCQs in your textbook. We will be discussing it together. Okay, I'm repeating it. It's page number 17, class 8. Okay, the first question is, I will read out the question as well as the options for you. Okay, I hope you have opened the textbook in front of you. The first one, hoisting a flag is related to. The name of the chapter is force, so definitely there is going to be push and pull over here. I repeat the question, hoisting a flag is related to push or pull or both push and pull or pressure. What do you think? It is pulling. Okay, you're basically going to pull the string to hoist the flag. So the answer for the first one is B. Please write it in the brackets. Now second one, a person is pulling water from well. Which type of force it is? While somebody is pulling water from the well, he is going to use his muscles, his arm muscles, so that he is able to pull the rope along with the bucket filled up with water. So this is going to be a muscular force. I'll mention the words also over here so that it is much clearer to you if you're not able to see the alphabet that I've written. Okay, now the third one, the force that a solid surface exerts on any object in the normal direction. They have given you a hint in the question itself. Read the question again. The force that a solid surface exerts on any object in the normal direction. If table is the solid surface and there is a book placed on the table. Okay, now the force exerted by the table on the book in the normal direction will be what? It is normal force. Okay, so which option is this? It is B and it is normal force. Next, fourth one. Please turn the page, it's page number 18 now. I'll mention it and 18. Okay, class? Okay, the fourth one. This is, please put a star mark on the fourth one. It has been repeated in innumerable question papers over the past. The fourth one, let the forces F1 and F2 act on the table in opposite directions. Okay, if F1 is greater than F2. Fine, if this was the table and somebody was pushing it from this direction as well as this direction. The force applied from this direction is F1. The force applied from this direction is F2. They gave us one condition that F1 is greater than F2. So if I want to find out the net force, I need to subtract both the forces. So the bigger number minus the smaller number, yes or no? Similarly, the bigger force minus the smaller force. So the net force is going to be F1 minus F2. Which option, class? It is the first option. Okay, A, F1 minus F2. I am reading the question again for you. Let the forces F1 and F2 act on the table in opposite directions. F1 is greater than F2. Okay, if both were equal, what would be the net force? It would be 0. This means the table is not moving. Okay, but they have given us a condition like F1 is greater than F2, and like your subtraction in mathematics, bigger number minus smaller number, the net force will be calculated like that. So F1 minus F2. Net force is also written as F subscript net. That is what they have mentioned over here, F net. Now the fifth one, a situation for effect of force leads to a permanent change in shape of object. Amongst the four situations given over here, which is a permanent change? Let's look at the options. Stretching a rubber band. Is it permanent? No. If I stretch the rubber band, I release it, it is going to regain the shape. It is not option A. Option B, squeezing sponge. If I squeeze the sponge, I release it, it comes back to its shape. It is again a temporary one. They are asking us a permanent one. Third one, pressing the spring. Same, it's temporary. I release it, it regains the shape. Fourth one, breaking the glass. I take a glass in my hand, I throw it down, it shatters into pieces. Can I rejoin them back and make it back to original, the shiny one again? No. So option D, breaking the glass. So that's all. Further, I will think and discuss with you. I'll write the questions on the board and we'll discuss it. Okay? Okay now class. So we are on page number 5, and it's the think and discuss is given over there. Think and discuss. Fine. You can take a pencil and note down the solution over there. A cricket ball of mass m is thrown with some initial speed. The mass of the ball is given as m. Okay. Now, if the air resistance is neglected, what forces are acting on the ball at half its maximum height and maximum height? So there is a ball with a certain mass m and it is thrown up in the air. Okay. And you need to calculate at its maximum height what is the force, and at half of its maximum height what is the force. Firstly, you need to remember, if a ball is thrown up at a maximum height, at this particular height the force is always going to be 0. Okay, so here the answer for the second part over here is 0. Now look at the first part, half its maximum height. This means somewhere over here, half its maximum height. This means there is still certain amount of gravity which is actually pulling the ball down. So at this point it is experiencing something called as gravitational deceleration. Now I'll tell you what is gravitational deceleration. Basically, it is the kind of gravitational force that is experienced in the reverse way. Okay, when the ball reaches the half of its maximum height, at that position, it is experiencing a certain amount of gravitational pull in the reverse direction. The gravitational pull in the reverse direction is called as gravitational deceleration. Okay, the next one, page number 6. Two identical bars, one is steel and other a magnet, are painted in the same color. How can you tell which one is a magnet? Okay, I take two bars over here. One of them is a magnet, one of them is a steel bar, and I paint them in the same color. How can I tell which of them is a magnet now? Both of them are painted in the same color. What will I do? I am going to sprinkle some iron filings. Okay. I'm going to place them on a sheet of paper and I'm going to sprinkle some iron filings, and if the iron filings get attracted to the first bar over here, this means there is a magnet, and this one is the steel bar, and vice versa. Did you understand? Okay. So we are discussing think and discuss, and we are going to continue with it. I've done the first two for you on page number 5 and 6. Now we are on page number 9. I'll read the question for you. Page number 9 on the right hand side, class. Think and discuss. A book placed on a table is at rest. Is the force of friction acting on it or not? So what if they say there is a table where I've placed a book. Okay. Now what are the forces acting on the book? Definitely, it is the normal force which is acting vertically upwards, and it is the gravitational force, or represented by Wg over here, which is nothing but acting downwards. And the book is at rest. Okay, if anything is at rest, is it going to experience friction now? No, only a moving body can experience friction, and it is going to be in the horizontal direction. If I slide the book, it is going to move with a force capital F, but it is not always going to move forever. At some or the other point, it is going to stop. That force which is stopping the book from sliding further is represented as small f, which is nothing but the frictional force. But in our case, they have not mentioned in the question like anybody sliding the book. The book is kept at rest, so there is no frictional force. Please mention it over there. Write it with a pencil. Maintain neat work. Now, next, on page number 10. This was on page number 8. Okay? Page number 10. Page number 10 on the left hand side, think and discuss. A system of two bodies A and B are placed as shown in the figure. How many forces are acting on A and B respectively? Okay, there is a diagram, something like this. There are two blocks which are placed on each other, one bigger than the other one, it's A and B, and they are asking us what are the forces which are acting on them. They are at rest. Did they mention that they are moving over here? No. Why is it necessary to separate contact force into normal force and frictional force? So basically they are asking us differences between normal and frictional. So what are the forces acting over it? Again the same replica. There is normal force acting in the vertically upward direction, and there is gravitational force acting downwards, vertically downwards. That is nothing but the weight of those two blocks over each other. Now, they are asking us, why is it necessary to separate contact force into normal and frictional? Because normal force acts in the vertically upward direction and frictional force is in the horizontal direction. These are two different forces. Okay, so for the answer here, mention that there are two forces acting. It is normal force and it is gravitational force. Now they're asking us reasons also. So what could be the reasons? Give at least two reasons. One reason is because normal force is vertical in direction. Put the second reason as frictional force is horizontal in direction. Keep things simple, they become easier. Yes, there we go. On page number 15, we have the last thing and discuss. Does pressure have a direction? What do you think? If I take a brick in my hand and I'm trying to insert it inside the sand tray, it is going in a certain direction. Okay, pressure has a certain direction. I take the marker in my hand and with a certain pressure I'm writing. Because of the pressure, whatever I'm writing is going to appear over here, not on that side of the board. So pressure has a certain direction. Okay, remember the brick experiment? The brick is going vertically downwards in the sand tray. It is going in a certain direction. So put a big yes over there. Does pressure have direction? Explain. Please write about the brick experiment over here. Refer activity 15, just above that. Okay, that's all in the textbook. We need to do the MCQs in your workbook also, and then we start the next chapter. Okay, so you need to open up your study material and you need to turn to page number 43. Okay, I'm mentioning it over here. It's page number 43. Open up page number 43 in your study material. I'm showing it to you which one to pick up. Okay, remember it is physics. Now, it is MCQs that we need to solve. There are about 50 MCQs. Let's try to do it together. Hope you have a pencil in your hand. Please maintain neat work. Don't use a pen. Use a pencil. Fine. The first one, choose the correct option. The first one is force is. What is the definition of force? It is a push or pull performed on a certain object to complete a task. So what is the option over here? Both push and pull. Option C. Fine. The second one, erasing the blackboard with the duster. When I am taking the duster and I'm erasing the blackboard, I am both pushing and pulling. So again here the option is C. Both push and pull. I hope you are noting it down and you're much faster than I am. So third one, only in the writing part. The third one, pen falls down due to dash. Why do you think a pen is going to fall down? What is going to pull it down? The Earth's gravity. So which force I need to mark over here? It is gravitational force. Option A. Fourth one, unit of force. I have discussed this with you. Named after a very famous scientist. I am giving you a hint. Hope you have marked it by right now. It is B. Newton. Fifth one, unit of pressure. I told you how to derive this. What is the formula of pressure? P is equal to F by A, or capital A over here. So force is measured in Newton and area is measured in meter square. So the units of pressure are Newton per meter square. Which option, class? It is option B. Newton per meter square is also called as Pascal. There are, okay? You can either call it Newton per meter square or Pascal over here. So it is option D. Sixth one, contact force. Okay, you're holding it. Look at the options. Is magnetic force a contact force? No, it is a field force. Electrostatic field force again. Gravitational force, again field force. Look at option number D. It is muscular force. Definitely you need to be in contact when you are exerting muscular force on an object. Okay, so now the next one. Seventh one. Non-contact force. Look at the options. Muscular force, magnetic force, normal, friction. Muscular, yes, you have to be in contact. Magnetic, no, there is no need of any contact. It is an example of forces at a distance. So option B, there we go. Eighth one, force exerted during digestion of food in the alimentary canal. While your food is getting digested, the muscles of your muscles of your stomach and the food pipe are going along, and working tediously so that the food gets digested. So it's option D. Ninth one, force can affect the state of motion of a body by. So, what are the effects of force on a body? Helps in changing the direction, changing the position, also helps in changing the shape. The option here should be all the above. And D, okay, please mention all the above. A push or pull is called. Come on, you know this. Push or pull is called as force. Option C. I'll erase this for you. So 10th one, I'm repeating it again for you. A push or pull is called as force. It's option C. 11th one, erasing involves erasing. Erasing the blackboard involves both push and pull. So again, option C here. 12th one, the SI unit of force. I just told you, named after a very famous scientist. It is option B, Newton. 13th one. Which one of these is not a contact force? Muscular force, yes, you have to be in contact. Friction, the objects need to be in contact. Normal, the book on the table, it is in contact. Magnetic, it is a field force. So option D. 14th one. The resisting force to movement of an object is called. What does this mean? If I'm rolling a ball on a smooth floor, it is going to stop at some or the other movement. This force which is stopping the ball from moving further is called as the resisting force or the frictional force. What is the answer over here? It is A, friction. 15th one. Dash force acts on the suspended body along the string. Do you remember the diagram? Okay. What do you understand? What do you recollect? What does it show? It shows tension in the string. So here it's B. Okay. Now, 16th one. The force is exerted by a charged on another charged or uncharged body. Remember the balloon experiment? How did I charge it? With the help of a paper. It became a charged balloon. Now the charged balloon was brought near some bits of paper which got the opposite charge and they started attracting the balloon. Okay. Now they got stuck on the balloon. So which force were we talking about there? It is electrostatic force. Which could be the other example? You brush a comb in your hair and it acquires a charge. You place it near the bits of paper. The paper gets attracted. Now 17th one. When the object is in non-uniform motion, it is said to be in dash. Okay, I'll answer this for you. You have not studied this one in the chapter. When the object is in non-uniform motion, basically you're standing on the ground and your friend comes and gives you a pat on the back and she says, come on, let's go faster. And you were at rest, but you start moving further. You're getting late for the class, so you're running now. So your motion over here is non-uniform motion. You have accelerated your speed. Okay, so that is why it is called as acceleration. 17th one is C. 18th one. A force can change dash, dash and dash of a body. It can change the shape, the position and the direction. So the option is D, which is all the above. Next, the force acting on a unit area of mass of surface is called. What is the formula? P is equal to F by A. Force here is represented as F. Force acting on an area, okay, on a unit area is called as what? Pressure. So which option should be marked, class? It is the C option, 19th one. 20. The unit of force in SI system. There are two, isn't it? What is it? It is both 1 and 2. It is Newton as well as kg meters per second square. How did kg meters per second square become over there? Newton you already knew that Newton is the unit of force. Now what is the formula of force? F is equal to ma. Now m is mass and can be measured in terms of kilograms. And acceleration, the units of acceleration are meters per second square. So this is how I get the unit of force. So which option do I need to mark over here? Option A. The unit of pressure in SI system. It is what? Pascal. Pascal or what else? Newton per meter square. Pressure is equal to Formula, P is equal to F by A. I have written over here. So F by A, can you spot F by A over there? Yes, it's option D. 23rd, the force of attraction between any two objects having mass. Okay, for example, the board has a certain mass, I have a certain mass. The force of attraction between us will be what? Remember the example? It is gravitational force. Now the force of attraction between me and the earth. Earth also has a certain mass. I have a certain mass. What is the force of attraction between me and the earth? It's gravitational force. So please write there option C. 24th, for the body at rest, the net force is nothing. The body is not moving. There is no net force acting on it. So it is 0. C. 25th, for a body at motion, the net force is, what is it? Is it 0? No, it is never going to be equal to 0. It is option C, not equal to 0. 26th, if the area is less, then the value of pressure is more. Okay, why is it more? I give you an example of a sharp knife. If the knife is sharp, the pressure on the apple is more and the apple gets cut perfectly. If the knife was a blunt one and the area of contact of the knife and the apple was really larger because of the bluntness, this means I'm not able to cut the apple. Okay, do you understand? There's no pressure then. 27th, the force acting in the normal direction. Why do you think I'm stressing on the normal direction? Because in normal direction, only normal force can act. Okay, this is pretty simple. 27th, B. Fine. 28th one, the force exerted by using our body muscles. Muscles. What do you think? It is muscular force. It is A. 29th one, light poles. There are two laws of magnets. Unlike poles attract, light poles repel. So light poles of a magnet, what do they do to each other? They repel. What do you mean by repel? They move apart. So it's option B. 30. Unlike poles of the magnet, you should be knowing this one and already marking it before I write it on the board. It is attract. Opposite poles or unlike poles are always going to attract each other. 31st one, the diagram showing all the forces acting on an object at a particular instant. Do you remember? I've drawn a man in a car and I showed all those forces around him. FBD. It is called as the free body diagram. Option A. Okay, 32. Which of the following statements is correct about a force? It can be seen but it can't be felt. What do you think? Can you, let's look at the other options. It is needed to start a moving object. It can change the shape of an object. It can make moving object stop. I think it should be, the question should be which of the following statement is not correct about force. It is option A. Can you see force? No. Please make a correction in the question. 33rd one. Which of the following actions involve both pulling and pushing? Typing a letter, does it involve pushing and pulling? No. Closing a door, no, you're only pushing over there. Squeezing toothpaste, just applying a certain force. Wringing a wet towel, yes, you're using both pushing and pull over here. What do you mean by wringing? You have a wet towel and you're squeezing it and you're pulling it from both the ends. Okay, so it's both pushing and pulling. 33rd one, D. I hope you have made a change in the 32nd question. I repeat it, which of the following statements is not correct about a force? 34. A disadvantage of friction is that it creates heat inside a car engine. Of course, friction produces heat. You rub your palms together, that is going to produce heat. Now in a car, all those machinery is going to strike each other all the time, every time you turn on the engine and the car is moving. So this is a disadvantage. The first one itself, yes. 34th one, A. 35. A sharp knife can cut food much more easily because I just told you more pressure. Look at the option A. It produces greater pressure on the food. Yes, they have made our work very easy because option A is the answer. Now 36. With the increase in the weight of an object, the pressure increases. Of course, if I throw one brick down, it is going to create a certain, mark on the sand tray. I throw two bricks down. The marks are going to be bigger. Yes or no? Because it is heavier. The more the weight, the more the pressure. 36. A. 37. Which of the following statements about force is incorrect? A force can change the mass of an object. You think a force can change the mass of an object? I'm holding the book. Is it changing its mass? No, I'm not tearing the pages here. I'm just holding it in my hand. It's not changing the mass. So it's option A. 38. Pressure can be increased by. What do you think? What is the formula? P is equal to F by A. P and A are inversely proportional to each other. Lesser the area, more the pressure. Let's look at this. Pressure can be increased by increasing both the area and force. No. Decreasing the area and increasing the force. Yes. Option B. Because area and pressure are inversely proportional and pressure and force are directly proportional. So you need to decrease the area and increase the force. So now 39. Pressure varies with force. Okay, it's basically asking you to denote what is force. It is capital F, A. Now 40. For study the above diagram, why the given object does not move. Because if the object is not moving, this means both the forces acting on the object are equal. So option C, both the forces are equal. Now 41. An action that involves pushing is dragging a bag. No, it is pulling. Kicking a ball. Yes, it is pushing. So option B. 42. Pressure depends on. What does the formula tell you? It depends on both force and area. So what is the option? Option C. 42nd one. 43. Which of the following statements is incorrect? So friction helps us to twist an object. No, it is force that is going to help you to twist an object. Friction is the force that opposes motion. This is correct. A and B are correct. Fine. Friction helps us to twist an object. This means you're applying a certain amount of frictional force in the machinery, basically. Third option. Objects have weight because of frictional force between them and the earth. No, it is because of the gravitational force. So the incorrect statement is C. Forces have dash as well as dash. What do you think? They have a magnitude as well as direction. Okay, it is option B. Magnitude means a certain amount, how much force is being applied to a certain object. Direction means they're going in a certain direction. 45. Play carom board with your friend. Does the coin always move in the same direction? No. 45. Option A. 46. Praveen is unable to lift a box off the ground. It must be very heavy and he must be a very thin boy. The force that makes it difficult to do so. There is gravitational pull of the earth which is pulling it down and making it more heavy, and also the weight of the box, of course. So it is 2 and 3. Option C. 47. Read and study the given actions carefully and answer correctly. Where the friction is useful. Striking a matchstick, yes. You need friction over there. Writing with a pencil, of course, you need friction there also. Pushing a cupboard from one room to another. You want to make your work easier, so you don't need friction over there. You need a smooth floor so that you can push the cupboard very easily from one room to the other. It is not option 3. Fourth one, sharpening a knife. Yes, you need friction over there. If there's no friction and you're doing it on a smooth surface, then the knife might slip from your hand or slip from your hand and you might get hurt. So it is option 1, 2 and 4. C. 48. Which of the following statements is correct about force of gravity? The larger the mass, the greater is the gravity. Force of gravity is commonly called weight. It makes the moon go around the earth. The larger the weight of an object, the greater is the gravity. What do you think? Because of gravity, the moon goes around the earth, the most obvious one. So 48. C. 49. Study the figure given below. At what point the pressure is the greatest? Definitely, the deepest point the pressure is going to be the greatest. It is option C. 49. 50. Pressure exerted by a sharp needle on a surface is more because the area of contact is less. If the area of contact is less, this means there is more pressure acting on the surface. If it was a blunt needle, it would be lesser pressure. Which option do you think, class? More than the pressure exerted by a blunt needle. I repeat it for you. Pressure exerted by a sharp needle on a surface is more than the pressure exerted by the blunt needle. 50, option A. I hope you're clear with this. Okay. So we are going to start the next chapter. The name of the chapter is Friction. Let me give a short introduction about it. Basically, we are going to learn about frictional force again. What is frictional force? What is the most simple example that we deal with? We have a ball moving on a smooth floor and you roll the ball on the floor. At some or the other point, the ball is going to stop. This means there is a certain force acting on the ball which is not allowing it to move further. What is this force called as? It is the frictional force. What is the definition of frictional force? The limiting or the resisting force which is causing the object to stop its motion is called as frictional force. Now, what is friction? Okay, what do you think? It is a basic quality produced by a certain object or because of the surface being rough or smooth. We will deal with this further again in the next video. Thank you. So the next chapter being friction, you need to remember a few points over here. Friction slows down the movement of an object, okay, and it is possible only on a rough surface. If the surface is smooth, then there will be lesser friction, okay. So basically on a greasy surface, there is going to be lesser friction when compared to a rougher surface. So friction is nothing but like a stopping or slowing down the motion of an object or the movement of an object. Okay, now you should think, why is friction necessary in your day-to-day life? What would happen if there was no friction? You would not be able to write. Okay, while you're writing with your pencil in your notebook, the lead particles of the pencil are wiping off over the paper and you can see what is written. Okay, you need to stop at a moment. You cannot be writing all the time. That rest, that slowing down of your motion of your hand is nothing but because of friction. Okay, let's talk about this now. In the car there is so much machinery. Okay, you use the car for more than 5 years, there is wear and tear of machinery. Why do you think this is wear and tear of machinery? Because of friction, because of those wires and those machinery were in contact with each other for so long and they were producing so much heat. So you need to remember one more point, that friction produces heat. Okay, now we will deal with further details in the next video. Thank you again.